Are we alone in the universe? Why is there life on Earth but not on other planets? Okay, so in order to try and answer all of these questions, we would have to go back to 1950 when Enrico Fermi and a few of his colleagues were eating lunch at the Los Alamos National Laboratory. We may never know what they ate, but we do know for sure that they discussed UFOs. In particular, Fermi made a comment that would become extremely well known. Fermi posed a question that has puzzled scientists for decades. Where is everybody? This question led to the creation of the Fermi paradox and the rare Earth solution. Despite numerous searches and studies, we still don't have a definitive answer to Fermi's question. But what are the chances that we'll find out? Let's delve into the mysteries of the universe and find out. The Fermi paradox refers to the high probability estimates for the existence of intelligent life beyond our planet, but we have yet to find any evidence of it. And as you're aware, when there is anything we don't understand, we try to create a theory. And as the years have passed, several hypotheses have been put forth to account for the Great Silence's endurance. This is what is commonly referred to as the rare Earth hypothesis, which suggests that the conditions necessary for the emergence of life and complexity may not be common in the universe. They are theories that may explain why we seem to be alone in the cosmos. Some of them are hopeful, while others are quite scary and pessimistic. As we all know, the discovery of extraterrestrial life would forever alter the course of human history. Imagine the excitement, shock, fear, and intrigue we would feel at seeing life on another planet. So, why is it that in an infinite universe with countless stars and planets, we haven't found any signs of life beyond Earth? In short, this theory suggests that Earth is a one-of-a-kind paradise for complex life. The conditions that allowed us to thrive are extremely rare and may not exist on other planets. Now, this hypothesis covers a lot of ground. It looks at all the factors that make Earth special, from its location in the galaxy to the makeup of its atmosphere. Essentially, it's saying that we may be the only game in town when it comes to intelligent life. But hold on, it gets even more interesting. Some people speculate that there could be other intelligent beings out there, but they're just too far away for us to ever make contact. Or maybe we're the first ones to evolve and will be long gone before any others have a chance. And then there's the theory of hibernation. This one's a little creepy, so brace yourselves. According to this idea, aliens could be in a state of deep sleep, waiting for something. But what? Well, some people think they might be waiting for the universe to cool down so they can crank up their computer power. And as any computer nerd will tell you, colder temperatures equal better performance. The rare Earth hypothesis posits that Earth-like planets might be few and far between. But hey, at least we know we're special. And who knows, maybe those hibernating aliens will wake up someday and we can all have a cosmic coffee date. So, we've mentioned the rare Earth hypothesis quite a bit in today's video, but do you know where it comes from? The term rare Earth was coined by two professors at the University of Washington, Peter Ward and Donald E. Brownlee. These guys are experts in paleontology, the study of ancient life, and astronomy, the study of the universe. They also wrote a book called Rare Earth: Why Complex Life is Uncommon in the Universe. In this book, they argue that there are certain features of Earth, our sun, and the solar system that makes our planet a suitable and hospitable place for complex life. Now, this might not sound like a big deal, but it actually has some pretty significant implications. See, most of us in the astronomy community assume that there are plenty of other planets out there that are similar to Earth. We call this the Copernican principle. This assumption is based on the idea that the universe is isotropic, or the same in all directions on a large scale. It's like if you were standing in the middle of a sphere and you looked in any direction, it would be the same. This idea also fits with the Copernican principle, which says that if you randomly sample something, it's likely to be representative of the whole. In other words, if the universe is isotropic, then it's likely that there are lots of Earth-like planets out there. But if the rare Earth hypothesis is correct, it would mean that Earth is actually pretty rare and special. And that could be a problem because we rely on the assumption that the universe is isotropic in order to study things like galaxies, stars, and planets. Without that assumption, it would be really tough to make accurate predictions about the universe. So, what makes Earth so special? According to Ward and Brownlee, some of the key factors include the following. First and foremost, the planet or moon needs to be in the habitable zone, or at the ideal distance from its parent star. This is important because if it's too close, the temperatures will be too high and the water will boil off. However, if it's too far away, the temperatures will drop and the water will freeze. Essentially, the planet or moon needs to be in the Goldilocks zone, not too hot, not too cold, just right. The star itself also needs to meet some strict criteria. It needs to be the right size and luminosity to support the evolution of life, and it needs to have the right kind of atmosphere and temperature. If the star is too small or too dim, it won't provide enough energy to sustain life. And if the star is too large or too bright, it will be too hot and the planet or moon will be uninhabitable. And to top it all off, the planet or moon needs to have a stable orbit. If it's too far off course, the temperatures will be all over the place, which isn't exactly ideal for life. Imagine if Earth's orbit was unstable. We'd have some seriously extreme weather. So, as you can see, it takes a lot of factors to come together just right in order for life to exist on a planet or moon. And that doesn't even take into account the conditions on the planet's or moon's surface. The rare earth argument is based on two hypotheses. The first is that microbial life is common in planetary systems. This means that it's likely that there are lots of planets out there with basic, single-celled life forms. The second hypothesis, on the other hand, states that advanced life is rare in the universe. When we combine these two hypotheses, it means that Earth-like planets with complex, multicellular life forms like animals and planets, may be the result of a series of events and circumstances that are pretty rare. This argument was actually a response to the assumptions and biases identified in the Drake equation, which is a formula used to estimate the number of extraterrestrial civilizations that might exist in our galaxy. The Drake equation assumes that intelligent life should be plentiful, but the rare Earth hypothesis challenges this assumption. Ward and Brownlee, the authors of the book on the rare Earth hypothesis, wrote, "The solution to the Drake equation includes hidden assumptions that need to be examined. Most important, it assumes that once life originates on a planet, it evolves toward ever greater complexity, culminating on many planets in the development of culture." In other words, they're questioning whether or not the evolution of life on Earth, from single-celled organisms to multicellular creatures with tissues and organs, culminating in animals and higher plants, is something that happens on every planet. Maybe it's just a rare combination of events. That leaves us with one final thought. Are we really alone in the universe? It's a question that has fascinated scientists and the general public alike, and it's one that we may not have an answer to for quite some time. Hollywood has certainly played its part in fueling the imagination with movies that speculate about the existence of complex life beyond Earth. But unfortunately, we don't currently have any concrete data to suggest that any life exists somewhere else in the universe, let alone complex life. That being said, astrobiologists and other scientists have ideas and theories about the prevalence of complex and intelligent life in the universe. And in the 2 decades since the book Rare Earth was published, interest in these ideas has only grown. Last year, astronomy caught up with both Ward and Brownlee, the authors of Rare Earth, to discuss the hypothesis. Ward even shared how the whole concept of the Rare Earth hypothesis spawned from a movie-based chat with Brownlee. He said, "We were just talking about how ridiculous the Star Wars ballroom scene was. That's how it all started. Look at all those aliens. You know, I just think the notion of aliens everywhere has been hoisted on the public." But Ward and Brownlee also challenged many widely held notions that supported the idea that complex life is out there waiting to be found. For example, while astronomer Carl Sagan often opined that our sun is an unremarkable star, in reality, about 80 to 95% of stars are significantly different from our own in terms of size, mass, luminosity, lifespan, and many other factors. Additionally, plate tectonics was not considered at all by previous researchers trying to explain why life on Earth is so plentiful while being so uncommon in the cosmos. Plate tectonics refer to the movement and collision of Earth's crustal plates, and it plays a huge role in shaping our planet into a hospitable place for life. It helps build up land masses, create diverse ecosystems, cycle carbon in and out of the atmosphere, prevent a runaway greenhouse effect, and stabilize global surface temperatures. Interestingly, Earth is the only body in the solar system that we know of with active plate tectonics. There are also many other features of our planet that make it conducive to life that we haven't seen replicated anywhere else in the universe. We are still left with the question we started with. Are we alone in the universe? Or are there other planets out there with similar conditions to Earth? It's a question that may remain unanswered for some time, but the answer would have significant implications for our understanding of our place in the universe.